In the first meetup, I have presented a case study that is also related to AWS data lake. And now I'm here with the proof of concept that I have worked recently. So, coming to the seamless integration with the business, as you all are Postgres work experts. So, we have chosen Postgres database as a source. So, coming to the first one. Coming to the business case. Coming to the business case, actually, this is the problem statements we got. This is the business case actually. The problem statements. What are the main points actually the client are facing? First of all, the exponential growth in the business data. So the current infrastructure, what exactly we are handling doesn't support the exponential growth of data. So to compensate that, we design a better infrastructure that we have designed. We can go through the next slides. Then the second problem statement is cost effectiveness. As the data, as there is an exponential growth in this data, there is also an increase in the cost like based on cost of storage, the processing of the data, and maintenance. And third one is the scalability. As these 3 points are interlinked actually. As the cost increases, as the infrastructure doesn't support, the scalability is also the main reason. So it doesn't hold the growth of the data. So these are the main points we have to design this POC. So as our company name OpensourceDB, we will mostly prefer to choose open source tools. So we have chosen all the open source tools like Apache Spark, Apache Drill for integration and for querying this data. So before whatever the open source tools we are using, we have to keep in mind these support challenges. This is the source we have source code we have generated from the 2024 State of Open Source report. So these are the challenges we have to keep in mind. First one is keeping up with the updates and patches. This is the top in the list. So while the current versions are, you have to keep the current versions, our latest versions to be installed to maintain the integrity of the, to maintain the smooth work. So you have to keep in mind the updated update. Coming to the second, personal experience and proficiency. So open source tools we must have trained professionals to handle the tools so that we can achieve whatever the issues to be handled or whatever the things we have to work out. So there should be some experienced personnel to handle these tools. And coming to the next, installation, upgradation, and configuration issues. So not only our servers should be updated, the versions what we are installing for these processes should also be the latest versions that we have to keep in mind. And coming to not enough personnel. So as it is mentioned in the personal experience, so the resources is purely related with the work presented. So as we have a good resource, we can present our work in a better way. So that is enough personnel we have scalability issues. So we are choosing open source tools. So in this open source tools also we need to keep in mind that they are scalable as per the data needs of the business, for what we are choosing. So that is also we have to keep in mind. Coming to the backup and recovery, as it is as the data is the main cornerstone, so we have to keep in mind that the data should not be lost, should be recovered in a better way, and to maintain it in a proper way. So we have to keep in mind that backup and recovery strategies. Then lack of documentation. As we are open source tools, we know that there is not a complete and clear documentation. So we have to keep in mind, or we have to document ourselves or for future references to the process of setup, installation, and everything. So that is the thing we have to keep. And coming to the commercial support cost, we are choosing the open source tools to mainly compensate the cost. So we have to keep in mind that some of the open source tools have community versions and enterprise versions. So as per the need, if you go with the next enterprise versions like that, it doesn't compensate, but with what exactly are most to use the open source tool. So that is also we have to keep in mind. Next, distributed computing and crashes going offline. So these are the points we have to keep in mind also. Handling the open source tools, we have to keep in mind. So this is the based on keeping all these points in mind. We are choosing some of these open source tools for working on this proof of concept. So based on I have mentioned the business statement, case problem statement. So based on the problem statement, we have created some opportunities. What we can do to sort the problem statement. So coming to them, cost optimization to efficient data handling. So I have mentioned the open source tools Apache Spark and Apache Drill. So for this integration, we are also using S3 to archive the data. So S3 is mostly, we can choose it as an cost optimization solution because it is it archives a huge amount of data in a efficient, in an affordable cost. So that is the main point we can keep in mind. By using the open source Apache Spark, the integration between the Postgres database and S3 to transform the data into the Parquet format. That is Parquet is a columnar storage which can be compressed and we can handle the data, and it is stored in archived in the S3. So coming to scalability for business growth. So obviously S3 acts as a good scalable one. As I mentioned that around 10 to 15 gig of data. So not only for current data handling, but also for future needs, it can be an agile source to scale for the future enormous growth of the data. So next one is improve operational efficiency. So we can improve this operational efficiency is the main point to get a seamless integration without any breaks. So for that we improve operational efficiency also have to keep in mind to load this data, seamless loading and transformation and querying this data. Coming to strategical use of resource, we are using, as we mentioned, that we are using Apache Spark to load this data into S3 and using Apache Drill, which is an open source tool for simply querying this data and data-driven decision making. So we are making this data in the Parquet format in the S3, but we are making the data in the Parquet. So we are storing the data in Parquet format, which is easily presentable to the business analyst by using Apache simply query. By that, by easily converting the data into a readable format, by this they can make a data-driven decision making easily. So these are the opportunities you have in defined as per this problem statements. Next, coming to the proof of concept course. What exactly we are going to achieve in this proof of concept? So first is unified data strategy. So as I said, unified data strategy means the different aspects like from ingestion of data to analysis. So first of all, for ingestion of data, so we our source is Postgres. So from Postgres to we are loading to S3 using Apache Spark. For this, we have to get a connectivity between the Postgres database and Postgres database with S3 and Postgres database with Spark and Spark with S3. So Apache Spark has an inbuilt feature. We can connect it. We can simply configure S3 to Apache Spark. So and but we have to install some of the JDBC drivers to work with the Apache Spark to use Apache Spark with. So like that, we will load the data into the packet format. Then we into the packet format. Not only we can, here we have used not only S3 and packet format, we also transform the data into this on-premise like into a packet file format also. Further also we can use Apache Spark, and also we have used Python code. We can, as we mentioned in the previous talks, that the code can be in Perl or Python scripts. We are using this Apache Spark supports Scala, Python, different formats of code. So we are using Python code for this. And coming to the agile data infrastructure, as we mentioned, the current data infrastructure doesn't support to hold that 10 to 15 TB of data. So that we have chosen this. So Apache Spark is also is a distributed packaging engine for large data set. So it will be mostly, it can handle a huge amounts of data for transforming. And S3 it is also scalable archiving storage one. So by this, not only the current data needs, we can also satisfy the future business data needs. So this is what agile data infrastructure we are going to achieve in this POC. Coming to the cloud-driven efficiency, both Apache Spark and S3 both we can use with the cloud and on-premise also. So by this we are going to achieve cloud-driven efficiency by handling this data and performance excellence. As Apache Spark is an in-memory performance, and Apache Spark has a in-memory performance ability, so it can handle huge amount large data sets without any breaks. So we can achieve performance excellence also. Coming to the holistic problem solving, by this POC, we are not only talking about the archiving this data, handling it, but we also talk about storage, processing, and maintenance of this data. So all these points are being covered in this proof of concept. And also we are making this packet format data or other format data into a readable format to the business analyst and business ready analytics. This is also talks about the same. We are making this unreadable format data into a easy readable format. So these are the POC goals we are going to achieve in this overall process of the proof of concept. So coming to the next slide, which is the actual architecture. So this is the architecture we are talking. I have mentioned that Postgres is the heart of our Previous slides. What is the flow of the data? So first we have a PostgreSQL database, which is handling around 10 to 15 GB of data. And to reduce this load from this Postgres, we are archiving the data into S3. But in here I have mentioned we can also use on or on-premise. So we have mentioned both of these storages. So this is the integration tool we are talking about in the previous slide, Apache Spark. So so to connect this PostgreSQL with Apache Spark, we need to have a specific Jenkins drivers to be installed to work with integration between these two. And Apache Spark has an inbuilt S3 configuration. So we can simply give that path of this S3 bucket and we can create a connectivity between these two. So we have transformed this Postgres data into the S3 bucket in a Parquet format. So not only this, we have also done this on-premise. We have compressed this table data into the Parquet format into the files, the .parquet files. So and we have also calculated the time taken for this transformation, like from PostgreSQL to S3 in compressed format or compressed Parquet format file and not compressed Parquet file also. These are all the things we have gathered, and also we can also automate this process of migration, transformation from PostgreSQL to S3. That is by using Apache Airflow, and we can also monitor the issues or any hurdles that are occurring in between these transformations also by using Apache Spark. So these are the things we have. This is the process of flowing into data. So once the data is in S3 bucket or on-premise in a Parquet format, as we mentioned. So with this data, the Parquet format data is a columnar storage and that cannot be available for readable in a readable format. So that we have used an Apache it's an open source query engine, which as we mentioned in the previous talk that case insensitive thing. So like that here in this Apache drill, this is a schema injection that is we can read Parquet format data, Avro or no schema data also we can read using this Apache drill. So we have used this Apache drill. But before this querying with for querying this using this Apache drill, we have to create a connection between these. So for create Apache drill has inbuilt plugins for S3, Hive or different types of data. But we have to add, we can add additional plugins as per our need. I have added a PostgreSQL plugin to this Apache drill, and we have created a connectivity between Apache drill and PostgreSQL. We can query this table data also, and we have enabled this S3 plugin to Apache drill by simply giving our configuration like S3 access key details. So we can query this target format data also with the simple SQL queries using PgHyd. And it is making this different format data available for the business analyst. This is the whole architecture we are working for this POC. So this is all about the architecture.
So you are offloading the data? Are you offloading the data from PostgreSQL? Are you uploading the data? Are you just moving the data from PostgreSQL to Spark?
Yes. Transforming format. Changing from table format to Spark.
Spark. For that you are using Spark.
Yes.
Yeah. So we are pushing the data from Postgres to cloud, right?
Yes.
In basket format. So are you concerned about the order of transaction? Order of transaction.
Order of transaction.
Yeah.
So when you say concerned, the concern is more of
Order of the transactions that I see. Like, if we convert that to Parquet, right? We don't have them in an order.
right.
In CSV we get that. So is that concern or like no?
No, as of now we do not have any issues or we haven't seen any concerns from a retrieval standpoint.
Correct.
One thing I forgot to mention actually, I'm sorry. I said we can read this data from Postgres to Parquet and okay, and I mentioned that we are moving this Postgres data into the Parquet format. We can get back the data as a table. Once the Parquet format data we have downed into the S3, whenever we want that Parquet archive data, we can simply go to the PostgreSQL. Already have this connection together. We can simply get that Parquet format data using Spark and back to the table format. This is one more thing I have missed. So this is the architecture, flow of data. Landscape. So to perform all the steps we have mentioned in this POC, these are the technical landscape we need. PostgreSQL source database to create Spark jobs and to execute the Spark jobs. And to execute the Spark jobs, we need a compute resource and S3 and Apache drill. We will have to configure all these steps, all these in our server to handle to work on this POC actually. So these are the technical landscape we need. And coming to the success criteria, as I mentioned in this architecture, I can have efficiently load the Postgres table data into the Parquet format in S3 and also in the local into a Parquet format in a normal way and in a snappy and also in a compressed formats. And I can read. I can retrieve the data back from Parquet to table also. And I can easily have query this data using Apache drill, the table data, the Parquet data, and we have calculated the time taken for this transformation for reading the compressed data and non-compressed data also. And we have data accessibility and availability. The data is easily available, even if it is having a 10 TB of data. We can simply query and retrieve the data easily and it is easily available for us. And coming to scalability, as we have chosen S3, not only for now and if this 10 TB moves on to 30 TB also, we can easily handle the data with Apache drill, with Apache Spark, which is an integration with the large data, create an integration with large data set also. and we have successfully created cost effectiveness by choosing these open-source tools and S3. So this is all that we have achieved in our proof of concept. So these are the differences. We have done a series of blogs on this POC. There you can go through all the steps, screenshot that we have, how we set up this on our local, how we install a setup, and how I use codes to transform this data from Postgres to S3 and into the files, and how we queried this data. So you can go through these different links, log links that we have on our website.
So the Spark which you said,
Yes.
Spark is in your on-premise, or where do you say?
On-premise.
On-premise. And what is the size of your server, the Spark? Because you are getting huge amount of data, and then you have to push it to the S3. So your server should be sufficient to get all to execute all those queries. So how much? What is your server current?
So we tested in POC local within itself.
The question is, how are you staging the terabytes of data in your development environment before writing this thing?
No, it is the configuration. He's asking about the configuration.
What is the question?
The question is, see, you have like a huge amount of data, and then Spark is running. Spark is just orchestration. So you have data on all the tables or anything. You know the data you get maybe within 1 minute or 5 minutes you are getting 10 GB, 100 GB of data. So the Spark will handle it. So it will very slow in your same configuration where the Spark is running. You have those kind of space should also, RAM should also, and then it will transfer it to either S3 or some other on-premise data.
So basically, the Spark is on a parking lot that we have. The configuration of those machines that we picked up for our POC is very minuscule, right? Probably a 4 CPU box with 32 GB RAM. That's it. But when we are going to be implementing this on our customer solution, we will pick up a slightly fat configuration, right? And one other important thing that you have alluded already is Spark is just a parking lot for us, right? We are not going to be storing huge amounts of data on that Spark machine per se, right? But from a computational standpoint, Spark also gives us a lot of degrees in the parallelism, right? At what pace we would want to go, right? At what pace we would want to catch up with the amount of data the customer is actually pumping on a real-time basis versus the historical data that we will have to do, right? That is the balance that we are going to do, right? So the POC that Brahmini did is to prove a point whether this the entire stack works for us or not. But when we go to the implementation phase, we look at how much of parallelism we will have to take into account, right? How much is the ongoing data, the real-time data, versus the historical road that we have, right? So to catch up करने के लिए we will look at multiple parallelism options. Spark is pretty good in giving us these parallel options, right? So you can go to a degree of the amount of CPUs you have, you could actually go do that parallel stuff.
So Glue is also based on the Spark.
Yeah. हमारे पास उतना पैसा नहीं है भाई. हमारे पास उतना पैसा नहीं है. Right, jokes apart, Glue also has an open source stuff, right? But the egress and ingress that we will have to calculate, and when we calculated, when we did this small POC, it was relatively huge, right? The financial footprint is something very, very important for us, right? the customer is a government agency, and we would want to make sure the whole solution is stitched around open source stuff.
That is the party is also like the best way to
Yeah.
because it save
Like
90%.
application, not storing the data.